This instructional video is a follow-up to driving Metahuman with MediaPipe4U. Let's open the scene we made in the last tutorial. In the last video tutorial, several friends reported that the plugins folder could not be seen in the content browser. Let me say this by the way. You need to check Show Plugin Content in the settings in the upper right corner of the content browser. UnrealEngine will not check it by default. I have to say that this setting is really unreasonable. Now, let's start today's content. Last time, in order to save trouble, I made a wrong demonstration, and I opened the camera directly in Begin Play. Due to the project environment, the Begin Play execution order may be different. This can cause the motion capture to fail. So, let's first remove the action. Adjust the position of the blueprint node, because next, our nodes will be very complicated. Now, right-click in the content browser and we start creating the user interface. Name the UI blueprint wpare MediaPipe. Usually, the first step in the interface is to select and resolution. Put in a canvas panel and set the interface resolution to 1080p, which is the mainstream resolution. Because I am not familiar with I am used to writing Slate UI directly in C++. Explain here that canvas is not the best choice, but it is suitable for beginner. In fact, its performance is not good. You should use box and overlay layouts as much as possible. Place a button and use it to start our motion capture. I anchor this button to the bottom left. Fill the content of the button with a text field. Set button size to content. Set the text color. I will use black here. Sorry again, I'm not familiar with as a visualizer, and I don't even know how to set the linear color to a solid color. Now, place an image widget to display the video frame. I anchored it to the bottom right corner. Actually, it doesn't matter what the anchor is here. Because I wrote a blueprint function in C++, it can dynamically anchor to any position and automatically adjust the image widget size. Name the button and image widgets, and make sure U is visible is checked, because we'll be accessing them in blueprints. Save and compile the UI blueprint. Now, back to the MediaPipe actor blueprint. Because we have a lot of operations here, add an execution sequence node. We set the display mouse pointer at begin play and then do other operations on this node. The first step is to create an instance of the UI blueprint we just created. This video invalid operation may be a bit much, sorry for that. We save the created widget instance into a variable named UI. Now, start handling button click events and start MediaPipe4U motion capture when the button is clicked. Connect this process to an operation sequence node. Adjustment: this blueprint programming is really troublesome. It takes a lot of time for me to adjust this every time, and the blueprint still looks like a mess in the end. Next, we'll start working on the image display part, which is a little more complicated. The reason why it is complicated is that widget does not have a suitable material by default. A very simple material is built into the MediaPipe4U plug-in to display images. I am not a technical art developer, so I didn't spend too much effort on this. You can use your own material. There is a texture parameter on this material. We will use it later. There is a video texture created event on the MediaPipe holistic component. Hook this event to receive the video frame. To clarify here, These demonstrations are simply using delegates because I don't want to study binding usage. I usually use C++ for my own development. As you can see, I'm actually very unfamiliar with I'm used to Slate UI. Painful adjustment of the blueprint. You are tired of looking at it, and I am also tired of doing it. Create a material instance that will be used to draw the video frame. For the material type, I choose the material in the MediaPipe4U. You can use your own material. I still adjust the order of execution. I don't want to make wrong demonstrations. Save the created material instance to a variable. Blueprint programming is really hard to use for me. Locate the image control from the UI. Here, let's sort out the logic. Drawing a picture to the UI requires three things: texture, image widget, and material. The texture is in the MediaPipe4U event parameter, and the other two are ready. At this point, we only need to set the material to the image component and set the texture on the material. SetBrush is used to set the material to the image control. This action does not need to be executed in every event callback, so let's connect it to the node of setting material. It only needs to be executed once at startup. Draw the texture to the material, which should be hooked to the event of texture created. Remember the texture parameter on the material. Here we use the texture in the event to set this parameter to achieve the purpose of drawing the image to the material. With the image, we need to adjust the display size of the image according to the size of the frame. Use the anchor image function in the MediaPipe4U if your image is in Canvas. This function can save a lot of steps if calculated manually. The nodes here will be very complicated. No matter how hard I try to adjust the blueprint nodes, in the end the blueprint still looks like a mess. This function accepts the texture and the size of the texture, sets the maximum percentage to be displayed horizontally and vertically and the anchor position you want, and then automatically adjusts the image size and display position according to the ratio. The percentage here is set to 0.3, which means that neither horizontal nor vertical exceeds 30% of the canvas size. I set the anchor position in the bottom right corner. You can place it where you like. Connect the previously made nodes. It means that after adjusting the image position, set the texture to the material. In order to make you clear, I will repeat it again. The parameter name here corresponds to the parameter name in the material. The parameter value is a texture which can be found in the event parameters. It's finally finished. I hope you haven't been confused by these nodes. If you get dizzy, just repeat it a few times and you'll understand. Finally, let's refine it so that the image is only displayed when the motion capture is running. You can check whether the motion capture is running through the isRunning function on the MediaPipe holistic component in the tick event. Prepare to nodes to show or hide the image control. Get the isRunning property of the MediaPipe holistic component and connect to the node that displays or hides the image according to the return value. Done. Now compile and save this blueprint. Run it to see the effect. Oops, I forgot to put the UI to the viewport. Go back to the blueprint and add it. Because I recorded the video in real time and did not practice it, the order of operations in many places may not be reasonable. Please forgive me. Now, you see the button. Click it to start motion capture. Let's put another button to stop snapping. Copy the button for start capturing. Align it to the start button. Name the button and reset the text on the button. Back in the blueprint, add one more pin to the execution sequence. Hook the click event and execute the stop function of the MediaPipe holistic component. Test the effect. At this point, the production of the user interface is over. Next, I will teach you to quickly start using MediaPipe4U in the Unreal Editor without making a UI. Find MediaPipe4U in the window menu. Click the MediaPipe4U Toolkit's submenu. You will see a fully functional MediaPipe4U operation tool. The first button is to start camera motion capture. After clicking, the cameras on your machine will be listed. The front brackets are the index numbers of these cameras, which is the device ID parameter used for the start function of the MediaPipe holistic component. Clicking on a camera will start camera motion capture. Note that not all cameras are available because many are virtual cameras and may not be available. Let's take another look at how to capture motion from video. For video capturing, you need to add a streamer image source. To use Streamer, you need to install Streamer according to the documentation. How to install? You can find the detailed steps in MediaPipe4U documentation website. Here are the detailed streamer installation steps. I have added the component. You can click the Add button to search and you will find this component. After adding the video motion capture component, the video capture button in the MediaPipe4U tool will be available, but you will see that the picture capture button is still disabled. Let me add another component, static image source component. At this time, start the MediaPipe4U tool again and find that the picture capture button is available. You can easily capture data from a picture. It is also possible to drive your character from a video through this tool. It can also change the parameters at runtime. The tool also includes expression capture, which can calibrate the face and track the running status of blend shape. Here, you'll also see the currently available face capture solutions. These are expression weight calculated in real time. If you have a NVIDIA 20 series or higher GPU, you can also use NVIDIA's algorithm to capture facial expressions, and its effect is comparable to iPhone face capture. You can modify Face Solution to NVAR to enable NVIDIA expression capture. Before that, you need to read MediaPipe4U documentation and install NVIDIA AR SDK. How to install NVIDIA AR SDK, you can find here. Let's see the effect of NVIDIA algorithm. My machine is already very stuck. I will disconnect the video tracking in our blueprint first, because the video tracking is already included in the MediaPipe4U tool. Note, the MediaPipe4U tool is only available after the program is running. I use a video to observe the effect of NVIDIA expression capture. I didn't calibrate this face. You can see that NVIDIA's expression capture is already very good. Next, I will take you to experience face capture from Android device. It's a new feature in MediaPipe4U. Free users of this function can only use it in the editor and cannot package it. Here, I use Skirkby to mirror an Android phone. This is an open-source screen mirroring tool with extremely low latency over a USB connection. After preparing the Android device, we set the face solution on the face link actor to remoting. Remember to stop motion capture before modifying face solution. You can see the face solutions available in your current environment in the MediaPipe4U tool. After starting the capture, you will see your IP address here, which should be filled in the host of M4 Remoting app. Start M4U Remoting on your Android device. I don't want to show my face, so here I turn off the face display. Now, start the motion capturing and MediaPipe4U will receive the facial expression data from the Android phone. You can click the plus button on the M4 Remoting app to perform face calibration. By default, M4U Remoting uses GPU inference. If your device GPU inference fails, you can also switch to CPU inference. This is the usage document of M4U Remoting, and there's also an Android app download link on it. Thanks for your watching.